Section 2.5 is on compound interest. We have a compound interest formula. So B is your ending balance equals P, which is your principal, times 1 plus R over N. R is your rate as a decimal. N is the number of compounds. And T is time in years. We have an annual percentage rate, or APR. So if you hear of APR, it's annual percentage rate. And then we also have APY, which is annual percentage yield, okay, which has a formula as well. So we can always refer back to these formulas because we have open notes. All right, so make sure that these formulas are written down. Number 1, Jimmy invests $4,000 in an account that pays 5% annual interest, compounded semi-annually. What is his balance to the nearest cent at the end of 10 years? So B equals 4, it should be 4,000. Okay, 4,000. Okay, that's the initial principal or investment times 1 plus 5% as a decimal over 2 because it's compounded semi-annually. That's twice a year, so over 2. And raise that to 2 times 10. All right, N is 2, T is 10. 10 is years. Okay, multiply all that out. Remember, this part here is a power. All right, so use the up caret, all right, in your calculator, or however you use a power in the calculator. When you do that, your ending balance after 10 years would be $6,554.47. Number 2, Samantha deposits $1,500 into Park Street Bank. The account pays 4.12% annual interest compounded daily. To the nearest cent, how much is the account at the end of a 3 non-leap years? Okay, so here we have 1,500 initial deposit times 1 plus 0.0412 over 2. Okay, raise it to the 365 because you have 365 days in a year, times 3. Okay, so that's how you kind of set up your formula. All right, this part here should be, I made a mistake there, this part here should be 365, okay, because then it's 365 days, all right, compounded daily. Okay, multiply all that out, and that'll give you your final answer. So that's just the setup. Number 3, Mike deposits $5,000 in a 3-year CD account that yields 3.5% interest compounded weekly. What is his ending balance? So $5,000 is initial deposit times 1 plus 3.5% is 0.035 divided by 52 because there are 52 weeks, all right, in a year. Raise it to 52 times 3. Okay, at the end of 3 years, multiply all that out, and you'll get 53.36. Number 4, how much more does $1,000 earn in 8 years compounded daily at 5% than $1,000 over 8 years at 5% compounded semi-annually? Okay, so the main formula is the same. You got 1,000 for your initial principal times 1 plus 5% as a decimal is 0.05. Daily would be divided by 365. Raise it to 365 times 8 for 8 years. And then semi-annually, okay, same basic formula, the 365 goes to 2 because it's semi-annually, it's twice a year. So 2, and then raise that to 2 times 8. Okay, so the only difference there was daily, 365 versus semi-annually, 2. So daily would be $1,491.78. Semi-annually would be $1,484.51. The difference, you would just subtract the 2, gives you $7.27 difference. Number 5, Mike and Julie received $20,000 in gifts from friends and relatives for their wedding. They deposit the money into an account that pays 4.75% interest compounded daily. Will their money double in 14 years? Okay, so $20,000 is your initial deposit times 1 plus the percentage of the decimals, 0.0475, divided by 365 because it's compounded daily. Raise that to the NT, well, N is 365 because it's compounded daily, times 14 for 14 years. Okay. Multiply all that out, you're going to get 38,888.13. Did it double? Well, double would be 40,000, so we're not quite there. So the answer to that one would be no. Will their money double in 15 years? So the only thing you're going to change here in this formula is the t. Instead of 14 up here at the top, instead of 14, you're going to have 15 now. Okay, multiply that out. You get 40,000, 779.76. Did it double? Yes, because you're over 40,000. Okay. Number 6. Investigate the difference between compounding annually and simple interest for parts A through J. Find a simple interest. All right, simple interest formula is I equals PRT. Okay, so you got 5,000 at 6% for 1 year. So P is 5,000. 6% as a decimal is 0.06 times 1 for T. That gives you $300. Find the interest for a 1-year CD. $5,000 at an interest rate of 6,000 compounded annually. Okay. Here we're going to use our B formula that we just did in this section. Okay. So 5,000. So when it says simple interest, it'll ask you for simple interest. Okay. That's a set period of time, and you're done. So 5,000 initial deposit times 1 plus 0.06 for 6%. Annually, N would be 1 because it's 1 time per year. And it's 1 times 1. 1 time per year times 1 year. That'll give you 5,300. Okay. 5,300 minus 5,000 initial deposit gives you 300. So the results would be the same. Okay. It would be the same. All right, so for that one, for the 1 year set time, it is exactly the same. All right, reason being is because it's compounded annually, meaning 1 time. If it was semi-annually or daily, that would give you a vastly different number. Part D, find a simple interest for a 3-year CD at $5,000 interest rate at 6%. Well, we know a 1-year CD was at $300. Okay, so if it's 3 years, okay, for simple interest, you just multiply it by 3. It's $300 per year. Gives you a total value after 3 years of $900 worth of interest. Part E, find the interest rate for a 3-year CD at $5,000 at an interest rate of 6% compounded annually. Okay, here, since we're over our 1 year, we know we're going to get a different number now. Okay, so 5,000 times 1 plus 0.06 divided by 1 because it's compounded annually. Raise it to the NT. N is 1, compounded annually, times 3 for 3 years. Multiply that out, you're going to get 59.5508. Okay, that's your ending balance now. Take your ending balance and minus or subtract off your initial deposit of $5,000. Gives you an interest of $955.08. So compare the two results from D and E. Well, D we had 900 interest, E we had 955 interest. So when you compound it annually, you're going to get $55.08 more when compounded annually. G, simple interest, 6-year CD, 5,000, 4% rate. So 5,000 is your P, times rate, or R is 0.04, times 6 for 6 years, gives you $1,200. Find the interest for a 6-year CD at 5,000, interest rate 4, compounded annually. So here we're going to use our ending balance formula. So you got 5,000 as your initial deposit, times 1 plus 4%, divided by 1, because it's compounded annually. Raise that to the NT. N is going to be compounded annually, so it's 1 times T for 6 years. Gives you an ending balance of $63,2660. Okay, the difference there is you have $13,2660 worth of interest. So comparing our results from G and H, when you compound annually, you're going to make $126.60 more. And then for part J, the difference between the ending balance formula and the simple interest formula is simple interest gives you the amount of interest for just 1 year, where the ending balance formula gives you interest over the life of the loan. Okay, so they are the same for year 1, but after that, the compound interest always grows faster because you're always starting with a new starting balance. Number 7. It says Island Bank is advertising a special 6.55% APR for CDs. Manny takes out a 1-year CD for $40,000. The interest is compounded daily. Find the annual percentage yield from Manny's account to the nearest hundredth of a percent. So here is our second formula we had up in our notes. 1 plus R over N to the N minus 1. R is your rate, N is what compounds. How does it compound? So 1 plus 0.0655, okay, that's your interest rate, divided by 365 because it's compounded daily, raised to the 365 because again it's compounded daily, minus 1. When you multiply that out, you'll get 6.77%. Again, make sure you move it 2 places to the right to get a decimal to a percent. Number 8. An elite private college receives large donations from a successful alumni. The account that holds these donations has $955 million currently. How much would the account earn in 1 year simple interest rate at 5.33%? So $955 million is your principal times your rate, 0.0533 as a decimal, times 1 after 1 year. Okay, the simple interest would be $50,901,500. B. How much would the account earn in 1 year at 5.33% if the interest was compounded daily, round to the nearest cent? Okay, so here we have compounded daily. So we're going to use our ND balance formula because our N is going to be different. So here we have P as our initial principal, so $955 million, times 1 plus our percentage is 0.0533 divided by 365 because it's compounded daily. Raise that to the 365 for compounded daily times 1 for 1 year. Okay, that gives you $1,778,531. When you subtract the 2, you'll see that you have a vast difference. So you had a little bit more money when you compound daily versus just one time per year. How much more interest is earned by compounding daily as compared to simple interest? Well, that's going to be $1,377,030.93. Okay, and the reason why is every time you compound, you start with a new number. So the first day you start with $10. If it's compounded daily, you may have $11 to start the next day, and then $14 to start the next day, and so forth. When you do simple interest, you're just doing it one time. Okay, you're never starting with a new number. You're always starting with that first initial number. Okay, so that is the big difference between the two. Okay, and then part D we don't need to worry about really. All right, it's just kind of expanding a little bit. I just want you to worry about the two formulas, simple interest versus the ending balance formula. That's the big thing in section 2.5.